All right, now we're talking about some of the fundamental things that will help us really understand triangles later. Now we've done a lot with triangles in this chapter, and this is our last section. I would probably say it's one of the most important sections. So I know it's we're getting close to Thanksgiving break and everything, and you're really tired, but please make sure you focus on this one. On the first one, it says here, we need to understand the idea that sum of the parts is greater, you know, the whole is still greater than the parts. So let me give you an example here. When I have an angle, and let's say I just divide it up. Let's say this was 30 degrees, this was 40 degrees. We know the whole is 70 degrees. Do you agree with me that 70 degrees is greater than 40 degrees? Yeah. Do you agree with me that 70 is greater than 30 degrees? Right. The whole is greater than either one of its parts. Well, we're going to use that now with our exterior angle theorem. Now, remember, we knew with our triangle exterior angle theorem that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1. These were called the two remote interior angles, and this was called our exterior angle. And we learned that way back in chapter 3 when we were talking about the sum of the angles adding up to 180, and we found out these two would add up to be that one. So when we're working with this, it's a real logical conclusion for us to say the following. The measure of the exterior angle of a triangle is greater than the measure of each of its remote interior angles. Which, when you think about it, is really makes sense because sum of the parts equal the whole. The whole better be greater than either one of its parts. So your exterior angle is greater than your remote interior. Your exterior measure is going to be greater than your remote interior. Really kind of a common sense type thing. Now, I'm going to name these theorems. They are not technical terms, but they're some of the most common sense names. Now, I hope if you understand, how many of you remember the story of Goldilocks and the Three Bears? Well, remember in the story, and if you're in class, I'd give you the long version of this, but you get the short version, okay? That Goldilocks, the three bears, she was on a hike, she gets lost, she goes into the house, and there's the three bears' house, Mama, Papa, and Baby. You have small, medium, and large, all right? Baby's was always just right for Goldilocks, but Mama's was either, was bigger, was too cold or too hard or something like that. Papa was bigger than that. So we had the three size of the bears, and everything matched the size of the bears. The chairs, the food bowl size, everything like that. So we're going to use that idea with triangles, okay? So our two theorems are going to be called the Three Bears theorem and its converse. Now, this is not technical, but I want you to think about this just a little bit. Does the shape of a triangle's or length of a segment size and angles make a difference? Yeah, think about it. When I put my hands together here, and I have a magic, let's just say, segment between the fingertips. If I make the angle bigger, what happens to that side between my fingertips? It gets larger. If I make it smaller, it gets shorter. And then, you can make a lot of different parts like that. So the angle does make a difference with this side that's opposite of that. So we're going to use that to our advantage. So here's the first one here. It says if two sides of a triangle are not congruent, because if they're congruent, we know the angles opposite them are congruent. So this is non-congruent ones. Then the larger angle is opposite the longer side. Let me give you an example of this here in this case. They tell you that the length of segment AB is greater than BC. So let's just say this is 10, and let's say like this is 8 or 6, something like that. Well, obviously, if I put those angles together, it's going to have to be a larger angle than if I had the length of 6. So I know, and this is kind of how I think about it. I think like Papa and Mama Bear, okay? Papa Bear was the largest one. Mama's the middle-sized one. So that means the angle opposite, angle C, has to be the bigger angle. That's the Papa Bear angle. The angle opposite the mama bear side, the medium size, has to be smaller. The middle angle, because smaller the angle, smaller the side length. So we played like the matching game with it. So it matches either way. Now the converse, so this one we call the three bears theorem. And we can use that to talk about any length of sides after that of triangles. Now the next one's the converse. If two angles of a triangle are not congruent, then it goes the other way. The longer side is opposite. Remember, opposite doesn't mean touching, okay? Opposite the larger angle. So let's do this one again. Here we have our two angles. Say the measure of angle Z is greater than the measure of angle Y. So let's say this is 100 degrees. We'll say this one is like, I don't know, 45 degrees, something like that, okay? Now, if that's the case, Z is larger. Bam! That means that third side has to be larger. So if this is my larger angle, I get my longer side. Papa, papa, okay? If I have my smaller angle, I know this has to be the shorter side. So obviously segment XY is going to be greater than segment XZ. So we should be able to put these in order, okay? So this was our converse. Now let's go ahead and see if we can put them in order. Write the angles in order from smallest to largest. Well, with this one, I look at the sides. All three of these are going to be different sides. That means all three angles have to be different. So if I have a scalene triangle, I get three different sizes of angles, okay? Now if I'm going from smallest to largest, I always think of it like this. I'm going from the baby to the papa. So when I do that, I match them up. Now, smallest side is GH. That means here's the baby side, here's the mama side, and here's the papa side. So what's going to be the smallest angle? Opposite the baby. So there's your baby one. Which one's your middle one? Right, the mama. So that's your middle sized. Which one's your papa? The longest one. So it goes to the papa sized one. So let's name the angles now from smallest to largest using mama, papa, and baby. So what's our baby one? Angle F. What was our middle one? Angle H. And what was our papa one? Angle G. Think of it like the three bears.